Alright, let's see what's going on. See what's going on today. Bernie overpowers the booze, Pocahontas, Elizabeth, and I'm sad. I'm a little bored on all that. Let's see. Okay, let's see something. Let's go to something like this. Let's see how.
Welcome back to our mini-series on the history of life on Earth. So far, we've covered the Archean and Proterozoic eons, the first 3 billion years of life, which was mostly single-celled that whole time. Next comes the Phanerozoic eon, and here we're going to zoom in a bit to the first chunk of the Phanerozoic eon, the Paleozoic era, which lasted from 542 to 252 million years ago. Right at the beginning of the Paleozoic, there was a huge explosion of more complex life, and that's when things really started to get interesting. The Paleozoic era is divided up into 6 periods, and by the first one, the Cambrian, multicellular life, including animals, already existed. But it had not done much. Animals were simple things like sponges. They didn't have complex organs, and really, they weren't much more than lumps eating bacteria they strained out of the water. All that changed about 542 million years ago with the Cambrian explosion. There was an increase in oxygen levels just before the beginning of the Cambrian, caused by a boom in life that produced oxygen using photosynthesis. Scientists still debate how big this oxygen event was and when exactly it happened, but it might have made predation, the predator-prey relationship, possible for the first time, and the filter-feeding lumps got gobbled up. Predation involves chasing after things you want to eat, and that takes more energy than just sitting on the ocean floor waiting for food to come to you. To maintain that high-energy lifestyle, predators needed a whole lot of oxygen. Once predators evolved, prey started evolving better defenses and ways to run away, which led to predators getting faster and better at capturing their prey. It was basically an evolutionary explosion. Hard body tissues like shells and skeletons began to show up in the fossil record just before the Cambrian. It took a lot of energy to produce that tissue, but it was worth it since these animals were less likely to be eaten. Officially, the beginning of the Cambrian was when animals started to burrow under the thick mat of bacteria on the ocean floor to escape predators. These predator-prey relationships combined with other factors like changes in the minerals in the oceans and flooding that opened up shallow habitats. This led to such an enormous boom in diversity that almost every major animal group that exists today evolved during the Cambrian, including arthropods, mollusks, and the chordates that eventually gave rise to vertebrates. The second period of the Paleozoic era was the Ordovician, which started 485 million years ago. This name comes from a Celtic tribe, since many of the best-studied rocks from the Paleozoic come from Britain. The Ordovician was when vertebrates first appeared. They were fish without jaws. Then came the Silurian period, named for another Celtic tribe, which started 443 million years ago. Sometime during the Ordovician and into the Silurian, life made the jump to land. Moving to land wasn't as easy as washing up on shore and going about your business. Life began in water, and living in water had some advantages over living in air. Water holds your body up. It helps you with gas exchange. If you release your sperm or eggs into the big blue, it's much more likely that they will meet up with other gametes to reproduce. None of that is true for air. You have to lift your body up, and in order to make the next generation, you have to get physically close to each other. So the earliest land organisms had to evolve support structures, new respiratory systems, ways to avoid drying out, and methods of of reproduction that were a little more controlled. Extremely simple plants might go back as far as the early Ordovician or even the Cambrian. They were spore-forming and had very little in the way of internal support. The oldest fossil we have that isn't a plant spore or a single-celled organism is a fungus called Tortotubus. It's about 440 million years old from around the Ordovician-Silurian cutoff. This fungus was a total game changer. Tortotubus probably helped pave the way for more complex plants and for animals too. It lived as an underground network of filaments, much like modern fungi. It might have formed mushrooms to disperse its spores, but we don't know for sure. It fed by rotting the few other organisms on land, likely early plants and microbes. By breaking down nutrients, it helped develop the soil on Earth's surface. That helped complex plants grow and develop soil even further. Now, there are Doctor Who creatures called Silurians, but they